Hello again, this is JP Schmitz with Global Scuba. We've got another instructional video for you today. It's about our test chamber. It's intended to give you some setup and basic operation background for the chamber to make it easier to use. In this case, we've got the 48320-DRO, which is our digital readout chamber, which uses a pressure transducer to read the pressure inside the chamber. So if we take a quick look at the chamber, just identifying some major parts, of course, we got the chamber body here, we got the chamber lid. This is the touchscreen interface box, and I'm going to turn it around and identify some of the other parts here briefly. So in here, coming out of the pressure port going into the chamber, we have two, those are overpressure valves. They're designed to release if the chamber becomes overpressurized. We buy them and use them from two different manufacturers to aid in redundancy. This particular part over here contains two items. The first item is our exhaust valve. This is used to take large volumes of air out of the chamber, essentially when you want to empty it. The other thing we have here is the pressure transducer, which is a instrument grade transducer, 0.25% accuracy grade, so sufficient for dive computers these days to perform your tests. So when we first start out with the chamber, we need to get some basics hooked up with the DRO, very simple, quick connections. The touchscreen assembly will come in one piece. There's a simple little jam nut here. We just put that on there and tighten that jam nut so it's securely on there, square and level. Then here we have the pressure tube. This is the tube that actually goes and pressurizes the chamber. We simply just turn this guy on here. Get it snug tight with our fingers. Use a 7/16 wrench to get it down for no leaking. Quick and easy. This is the cable for the transducer. This cable is keyed, which means when you put it on the transducer, it actually has an angular orientation that it must follow. We assemble it to make it easy so you can kind of see the orientation where the angle connector is pointing back this way. Put it in there, move it just a little bit, and it'll slide up. And then once it slides up and in there, we tighten the nut, and it's secure. Looking at the back of the DRO chamber, there's two other things we want to look at. This port right here, this is the exhaust vent. So there's a push button exhaust on the front interface, which we'll see in a bit. That's the exhaust for it. This is actually the DC power port. The transducer and touchscreen operate on 24 volts. So we'll take the chamber and kind of rotate it back around again here. Observing quickly on this side, this particular port here has a male GIC connection. It is a high pressure port intended for dive computers that need tank pressure to activate. If we quickly look inside the chamber, we can see that that port connects to a high pressure swivel. Normally, if we're not using that swivel, there's a plug in it. When you want to use it, take the plug out. It's the typical 7/16 high pressure port that you would find on most chambers. So I am going to do a couple of things. I'm going to plug in the touchscreen and let that start warming up. And we'll go over some of the other interfaces here. So as the touchscreen comes up, we have two areas of control that we have on the front of the touchscreen. First is this push button here. This is a push button, little purge button that purges the pressure inside the tank. Its intended purpose is to allow you a quick and easy way to reduce the tank pressure if you slightly overshoot when you're filling it. So it's not intended to be a high volume dump. You would want to use this guy on the side when you want to empty the chamber completely. Here we have a needle valve. This needle valve is connected to our inbound pressure. We turn that on and off. This is what we use to fill the chamber with air. So the needle valve gets its pressure from this particular port over here. This is a standard BCD male connector, the standard Trader valve that you'll find on a BC connector. Here we have a hose. You can just plug that in. A lot of folks will use a first stage regulator on a tank with the BCD and connect it in here for their pressure source. So this applies pressure once we put it in there. So now the system is actually powered up and ready to go. One particular note in terms of dealing with electronics and measurement devices, even though electronics today are actually much more robust than they were before for temperature compensation, it's always recommended to get the most accurate measurements that you plug the system in, let the electronics warm up for 15 minutes or so till they stabilize. At that point, you're going to get the best measurements you can. So now looking at the chamber, here's a couple of things that we want to do on a regular basis before we actually run a test. So we have the chamber lid, which is here. The lid has a lens in it made of acrylic. This lens, every time we run a series of tests, we want to take this lens out and inspect it. We want to inspect it looking anywhere, particularly on the edges, for any cracks or chips, because we want to make sure that this is safe to use before we use it. So if we have any scratches or chips or cracks, that's something we need to take a note of and perhaps refrain from using the chamber. So you're always welcome to call Global and we can discuss it if need be. So when we're replacing the chamber lid and we're going to run a test, there's a specific orientation we want to put it on there. So we have lugs and then we have handles. On the chamber, we have a lock on one of the lug interfaces. That lug always needs to interface with one of the T-handles. So when we put that in there, we want to make sure that the T-handle is on the slot with this particular lock. So the O-ring on the chamber actually has a tight fit. It's pretty snug. So when you're actually pushing the chamber down, first step is we want to make sure it's free to vent. So we open this guy up so that as we push down, we change the volume in there. We need to allow that air someplace to go. So we kind of work the chamber lid down this way. We can hear some hissing coming out of there. That's the excess air escaping. So when we get it down on the bottom, we rotate it all the way till we get the full lug engagement here. To verify that we get that, we always move the lock down to make sure that the lock can fully engage. Then we know that we're actually locked in place. So after that, once we're ready to test and put air in the chamber, remember, close this guy, this dump valve here, and then that'll take us to the touchscreen interface. When the unit powers up, this is the normal home screen for the touchscreen interface. You actually have 3 buttons that we can use. One is read, the other is an about button, and the third is 0. So let's go to the about button first. That's more of a setup one that we use from time to time. That takes us to a setup screen. On that setup screen where you can set the date, time, and we do calibration. So time is quite simple to set. Change your values to the appropriate one that you want. Date, similar thing. Change it to the appropriate one that you want. Typically these will be set up to Central Standard Time in the United States when we program the display. You may need to change it for your particular time zone. So one more, we have what's called calibration. Calibration is a password protected area of the touchscreen interface. There are certain parameters in here that we use to specifically adjust and tie the pressure transducer that we use to this particular display. So unless you've got a situation where you've actually replaced the transducer with something different or a little bit more specific, perhaps metric units instead of English units, we may need to make some adjustments in there, but that is something that you have to work with us at the factory on if you want to change. So going back here, we now let's go to 0. So as with any devices that are out there that measure pressure, we always want to zero them out, which means we want to make sure we have 0 pressure in the tank. So always open the side valve, make sure it's free and that there's no air flowing, that everything settles down. And then occasionally, if this doesn't read exactly 0, we want to zero it. And we zero it simply by pressing the 0 button and holding it for 3 seconds. At which point, it will make any internal calculations to make the output pressure 0 equivalent. So that's adjusting for an offset, is basically what that's called in the data acquisition world. So now we go back to our main screen and we go to the read screen. So the read screen actually has a couple of things on it. The most important one is the actual pressure value that we're measuring. One of the advantages of the touchscreen is we can choose the units we want to see. In this case, we're showing PSI, but if we want to change the units, we can change, just press the indicator there, feet of fresh water, meters fresh water, feet of seawater, meters seawater, bar, kilopascals, and PSI. So you can choose any one of those ranges. All of the calculations and adjustments for it to accurately read in those given units are all designed internally and set up, so you don't have to worry about any conversion calculations. So we also display date and time there quite easily. We have also have a timer function, which we'll get to in a later video. So now we're ready to actually run a test, put some air into the chamber, and see how we do. So now we're ready to run a test. Let's go through some basic things for running a test to verify that we've set things up correctly. Always want to make sure that we've got the lid in, it's properly aligned and cogged with the lock on. So we verify that we're in the correct position, make sure that our dump valve is off, closed, and now we're ready to put some air in there. So we've applied pressure with a BC quick disconnect on the side, so we have air pressure available. So now let's start putting air in there. We'll do it slowly. The needle valve is designed to do small flows, so we can slowly move things up. You can kind of hear the air going in there. We see the pressure rising. One thing to note, and I'm going to stop it. We're going to stop it right here. One thing to note, you'll notice the lugs, they actually all lift up and start pushing on the top. So that's one of the ways that we know that we've got pressure in the tank. In this case, we've got 9.8 roughly PSI. So if we continue, we can open the valve up and you flow a little bit faster. And say get up to 20 PSI and we'll stop roughly. So we stop, I kind of overshot things a little bit, slow down, so we can always press the purge button to remove some air in there. One particular note on how the chamber works. We all know from filling dive tanks that when we go from a low pressure to a high pressure and filling a dive tank, they get warm. And when we go from a high pressure to a low pressure, they get cold. The same concept applies with the chamber. And the way we will see that is when we fill the chamber up, if we fill it up a little more quickly, the air inside the chamber, the temperature is going to rise. So as that rises, when we stop, one of the things you'll see is that air cools. We know that the pressure goes down. You'll reach a pressure, and as it cools down to a steady state, that pressure is going to go down slightly. So that's a thing to note that actually occurs inside the chamber. It's not a leak. It's actually just the thermodynamic process. So for most cases, when we're actually wanting to read a dive computer, test a gauge, what have you, that is the type of thing where we can quickly look in there and look up at the display to run our comparison. We don't really care if we're slightly changing at any particular time. If you really do want to hold things stable, depending on how fast you fill it up and how much temperature rises in there, you're just going to have to let it sit and equalize with the temperature. So now that we've got our pressure in, we again have the ability to adjust down with the vent button and up with the needle valve. So now that we're finished, we want to remove all the air from the chamber. Remember, we can always hold this button for an extended period of time because it doesn't flow very well, or we can use the dump valve. Open that up, and we can see, if you watch the display, you can actually see the temperature going down in the chamber. So even so, with the chamber and the exhaust valve on the side, it still takes a little bit of time for the chamber to empty out. If there's still pressure in the chamber because of the size of the lid, it will be nearly impossible to move it until the pressure is 0. So that's one thing to note. Someone could say, "Oh, I want to start it at 5 psi." You won't be able to move the lid. It's still too tight. So we'll see once we get down here, almost to 0 here. So the first thing that we'll note when the chamber is low enough to get the lid off it is we can take the lid and push it down to the bottom. See, I can push it down. So now I know there's enough air out of there, or I can get it out. So then I can remove the lock and I can rotate it that far. Now, because we have the tight fit in the chamber, it's easiest on the chamber and your back if you take your time taking the lid off. So what I typically do is I grab the handles like this and I put my thumbs on the side of the chamber like this, and I slowly rock and slowly pick up at the same time. And you can hear the air going in there as I bring the lid out. Lid's out. Do my work, whatever I want to do. If I'm not using the chamber, it's very important. The O-ring that's used for the lid seal is actually a big O-ring. It displaces quite a bit when it's inside the chamber. If you leave it in the chamber like this, all the way down where it's engaging the O-ring groove, it's going to take a set, and that O-ring will actually start to take that shape. We don't want that because that makes it more difficult to seal. So the quick and easy way to store the lid when you're not using the chamber, just rotate it a little bit, let it sit on the top like that. That way the O-ring, you can see, is not engaged in the O-ring groove. So it won't take a set. So that's really the best way to store the chamber lid. One other quick thing I want to go through, and this can make your life easier. You have to be very careful with the process as you do this. So when I have my lid in a normal test position, so that's the position it would be at the end of a test, and I'm ready to take the lid off, I do my first step, remove the lock, move the lid over to the point where it can eject. Now I can close this valve, and if I put a slight pressure in it, it'll actually lift it up quite easily. So if you watch the lid and the display at the same time, you can kind of see, I just give it a little pressure and the lid moves up. It frees it from the O-ring groove, and then it comes out super easy, very easy. And I turn it, set it on top like that, and store it. So this is the 48320 DRO chamber. Hope you found the video informative. If you have any questions or require further details, please call Global at any time.